Lecture 33, more on the normal curve. And I just want to have a little short lecture here to make sure we really kind of get the connection between a normal random variable and the normally distributed population of data. And I don't want to give a long-winded explanation up front. I just want to kind of walk through an example, and I think it'll kind of maybe clarify things a little bit. Okay, so I say here, recall that women's heights in inches are normally distributed with mean 63.8 inches and standard deviation 2.6 inches. So the way we will think of that, the language we use is if W is the height of a randomly chosen woman from the population of all of women's heights, then we have what? That's what we would say. W is distributed as, or has the PDF of a normal random variable with mean 63.8 and standard deviation 2.6 inches. Okay, well, what does that mean in terms of population of data? Maybe it's a little bit clearer if we just imagine for a second that we have the population of all of women's heights in the whole world, so all, I don't know, 1.5 billion adult women. Here we go, we've listed all their heights out right here. Okay, well, what we could do is, I say that we could draw height after height from this population. All right, I got this huge set. We keep randomly drawing heights, and when we draw a height, we draw a number, we could put that into our information that we're going to use to plot a relative frequency histogram. So suppose we did that. Suppose we grabbed randomly, the first height here. So let's see if I can circle it. Yeah, so I grabbed the first height, which sounds like I'm not being random, but just the height is just what it is. It's just anywhere, and that just happens to be the first one I grabbed. And then, let's see, I'm going to build a little relative frequency histogram. So I'm going to plop that down maybe where it belongs on the number line. This is the number line. I didn't put numbers on it, but that's where that height belongs. All right, let's grab another height, and we plot that one. Boom, and it's there. Let's grab another one and plot that one. Maybe it lands there, and do another one, and it's there. Do another one. Isn't this fun? It's there. Do another one. It's there. And suppose we keep doing this billions and billions of times, and we're going to eventually put together a huge data set, a huge relative frequency histogram. And let's see here. Let me get that out of the way. And you can see that what we end up getting is kind of a bell-shaped curve to the distribution of the data, right? And if we just keep going forever and ever and ever, we really end up with our normally distributed, didn't circle it very well, a normally distributed random variable there, which is a normally distributed data set. So right here, we have our mean of 63.8, and we go up like this, maybe out to about right, about right there. Sigma is 2.6 inches, right? So that's the thing you can draw down in the space below, and that's what you get after you heap all that data in according to its frequencies, and you end up with a bell curve, and it's indicated by that up there. All right.